Hello everybody, thank you for joining today. My name is Onu and today we're going to be covering radio waves. So some of our learning objectives include what are the components of a radio and how do they interact together to produce radio waves? What sort of different radio waves can be used for communication? And some things you should already know are the electromagnetic spectrum, okay? You should know where radio waves sit on the EM spectrum. If you don't worry, I'm going to remind you throughout the video. So let's get right into it. Now, let's go back to our EM spectrum. Our radio waves sit right at the edge of the EM spectrum here, and they have the longest wavelengths and the lowest frequencies. Now, these longer wavelengths are really important because this is what allows radio waves to be used for communication all around the world. But how does that communication actually happen? Well, here's the process right now, and it's actually quite simple. We have a device called an oscilloscope, right? So you might have seen it. It's usually shown with like a wave on a screen and it has like knobs, right? So this is called an oscilloscope. Oscilloscope. And this is just a machine that you use to read waveforms. Okay, so a waveform is literally just any other wave. It's a fancy word for it. Now, this oscilloscope is connected to something called a transmitter. Let's just do like that. Again, no R words for me. Transmitter. And it's in the word. These transmit the radio waves. Now, the next part is let's do it in a different color. Is the receiver. So these receive the radio waves given off by the transmitter. Receiver. See that? And that is connected to another oscilloscope. And on here, you get the readout from the radio waves. Now, what's really important, and you have to remember this, that the actual wave itself is produced. So let's write this. Radio wave produced by AC current. Now, AC stands for alternating current. So this tells us that the charges in the current are oscillating. So remember, an oscillator is just a cycle of a wave. They're oscillating, and that produces an oscillating radio wave. Because remember, all of these waves here in the EM spectrum are transverse, which means that they oscillate 90 degrees to the direction of energy transfer. So the radio waves are produced by alternating current, and let's write on the edge here. The frequency of the AC current is equal to the frequency of. Now, there are three types of radio waves you need to be aware of for your GCSE: long waves, short waves, and very short waves. So what are some of the differences between the three? Let's get into that. For our long waves, here I have the Earth, right, a small part of it, and I have my transmitter along here. Long waves can actually curve across the surface of the Earth. Now, why can do that? That's because they can diffract through the air. Now, if you remember, diffraction is the changing speed and direction of a wave as it moves through a different medium. As you get higher, it's higher above the Earth, we get different compositions of the atmosphere. You know, the densities of air change, so the radio waves slow down a bit and they curve, they diffract. So let's write that down. So long waves can travel extremely long distances, like I'm talking across countries, because they can curve around the Earth, and they curve due to what the full word is atmospheric diffraction, but diffraction is just fine here. The wave. Now we have short waves. Short waves can still travel long distances, but how they do that is a bit different. Let's do it in a different color now. If I have my red Earth now, short waves are actually done by bouncing the radio wave off of something called the ionosphere. Okay, so let's draw these arrows in first. The ionosphere, let's just draw it in there. Ionosphere is a charged portion of the upper atmosphere. Okay, so short waves travel by being bounced off, well, bounced, we should really say reflected because we're physicists and we use keywords all the time. Being reflected off the ionosphere. Okay. So shortwaves can also be used for Bluetooth connections between phones. Right, I know here I have being bounced off the other, you're thinking long distances. Shortwaves can also be used for quite short distances too. Then we have very short waves. So these travel not very far at all. Not very, oh my days, very far compared to long and short waves. And these need direct line of sight, so the transmitter needs to be able to see the receiver or very close to that. Okay, so some uses of very short waves is FM, sorry, not FM, both of them actually, is radios in car and TV signals. So this is why in a very stormy night you might sometimes lose connection from your TV. Well, that's because the rain is interfering with the direct line of sight from your receiver to the broadcaster's transmitter. And also why, if you go in very far away from, say, London and you want to listen to a London FM station, you can't hear it because your receiver in your car is too far away from the actual transmitter. So let's draw a diagram here. That's a bit small. If I have my transmitter there and I have, say, my car here, again, no artworks for me, and I have the little thing at the back, that's our receiver. The transmitter needs to be able to see the receiver for you to receive very short wave communication. Now you understand the 3 different types of radio waves you need to understand for your GCSE.